So on the location, seeing the photos.
Over pickup. Pickup. And not deliver.
Try to change it to delivery number. I think still got
Yeah.
I don't know.
Just Google it. Battery and Google.
One pepperoni, 220. Yeah.
Pepperoni, chicken, Hawaiian.
Oh, it is. So pepperoni, chicken, and what? Yeah. Yes. First. Yes. Yeah, so soda. Yeah. No say. Just the drink against the price. Yeah. Sprite. Yeah. Ooh. guys the delivery. The WhatsApp card. The WhatsApp card.
Cash.
Oh yeah. 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 Delivery. 575 842. Oh, 845.
Right. My screen should be my screen sharing. All right, guys.
The confidence and me.
Yes. Oh, yes. So welcome to the first physical meeting of the JIA, the Jamaica Artificial Intelligence Association. All right, so before we kick things off, we're going to start with a little icebreaker. So I'm gonna give you guys a little quiz. If you get the correct answer, there's a prize involved. I won't say what it is just yet, but there will be a prize. Say if you have the correct answer, I guess raise your hand and well, whoever raises their hand first, I guess wins. Eh? Well, yeah, you can't just blurt out the answer. If you blurt out the answer, then you lose. So you have to raise your hand first and then I'll call on you and then you answer this. All right, so ready. Here's the first question. So, which one of these guys was the inventor of the convolution? Is it A. Jeff Hinton, B. Andrew or C. All right, yeah, answer is C. All right, see if anybody else. Let's see if anybody else can get this one. All right, what year did DeepMind's AlphaGo beat Lead Step Doll? Was it A 2010, was it B 2016, or was it C 2030? No, no, it's not 2016. Yeah, 20,
Like that.
so yeah, 2026. All right, one last question. All right, so what is the main component of the infamous GPT-3? Is it a transformer, STM, or is it a convolutional neural? Transform, yeah. All right, so that's it for the quiz. So I guess Dimitri has 1, 2, and then Jordan has 1. All right, so what's the idea behind the JIA, or basic mission statement? So the idea is we want to spread awareness of AI in Jamaica and the wider Caribbean, and to facilitate research, development, and implementation of AI projects. So you guys hear about all the big achievements in AI in first world countries, such as the States or in Europe. The idea behind the JAIA is to essentially facilitate similar achievements in Jamaica. So my hope is to essentially create a community of, community of people who are passionate about AI, who maybe want to do research in AI or want to take up a career in AI. And my goal is that if you have a group or a community of people who are sharing their knowledge, sharing their skill sets, then hopefully that can help the field of AI to move forward in Jamaica. So also to facilitate AI education in Jamaica. So a lot of people hear about the term AI but have no idea even how to start, how to get into it. So they see all this cool stuff like steering wheel, self-driving cars, and they don't even know the first step. Where do I start learning this? I don't blame them. There's a lot of information out there. There's new knowledge coming out every day. So one of the goals is to facilitate AI education in Jamaica. So maybe have workshops, conferences, tutorial sessions. So I'm thinking is so that you guys can, this is the whole point of the meeting, so we can share ideas together of like best path forward. So a lot of people basically don't know where to start in AI education. So we could maybe, work together to create like a track, like a program. So start here, then the next step is this, then this, then this, then this. So basically, if you follow that, then you should have a decent amount of knowledge to do even your own research in the field. The third one I think is a good one as well. Is to help provide opportunities for Jamaicans to attain a career in the field of AI. So a lot of you guys probably want to take up a career in AI. Maybe you want to be a data scientist, or you want to be a machine learning engineer, or maybe you want to be an AI researcher. But again, you realize that there's maybe not a lot of opportunities in Jamaica for that. So one of the goals of this organization is to hopefully help you guys, if you guys want to attain a career in a specific subfield in AI, then we can work with you, find best employers and see what's the best way we can get you into some sort of employment track. And I know this first physical meeting is small, but as we go along, we'll be inviting like prominent people in AI. My hope is that maybe if we can get big enough, we can invite people from abroad, like international people. So even if they can't come physically, maybe they can speak virtually or something. Lastly, I know a lot of you guys have ideas for like AI projects. And I really like projects that are crazy. So the projects that a lot of people like, oh, this can't work in Jamaica. A big reason for that is funding. So I'm hoping that we can also help to fund AI-related projects as well. Give me a second. I think somebody's trying to find it. Oh, well. It seems that is at the wrong building. I guess you guys can try it.
Tell them to check the Discord chat because the location and direction is there.
Oh, okay. Oh, you put in the location. I'm good. All right. So becoming a member, I mean, just being here makes you automatic a member. So they have like sign up, so probably gonna create like a Google form, just give me information. Did I go all the goals? Oh yeah, we're trying to get at least 100 members. I think there are like 62 people in the WhatsApp group. So we can get to 100 people by the end of the year. I guess that's gonna achieve it. So what's the benefits really? So access to a network of AI enthusiasts. So I mean, as you guys know, a network is important within any field that you're into. Having a network is important. So just imagine you guys are working on a project. Maybe you're stuck at a certain place. You can essentially maybe call somebody in the JFK or just shoot a question in the group and somebody can help you out. So maybe you're stuck on a research problem, probably something that somebody has already done. Okay, maybe the loss, or it's not, your model isn't converging and somebody tells you that maybe you need to lower the learning rate or something. Probably some of you have experienced that same problem, as I just mentioned. And lastly, access to funding and expertise. So I think that's a big thing, like funding. So I'm actually looking to make this an official like organization and a non-profit. So hopefully we can get like donations and stuff like that. So if you have an AI project and you can map out like how you would actually go about creating it, and you work out all the details, then you can apply for funding and say you can actually get it. But I really think that there's a lot of body talent in Jamaica. It's just really for us to come together as a group, to make this thing work. So I'm very excited for the possibilities ahead. I mean, AI is a very big field now, like everything, every big company, Tesla, Google, Microsoft, Apple, there isn't a presentation without them speaking about something that has AI or machine learning involved. So it's a very good time to be in the field. It's a very lucrative field to be in right now. Like investors will throw money at anything that's an AI nowadays. So if you have like expertise in this field and you can show that I'm good at this or have a skill in the field, then it should really be easy more or less for you to make some even good money in this field. So my goal is to hopefully if we can create a community, then it will make it easier for people to get the right education and get opportunities to maybe even pursue a career in the field. I think that's the biggest thing right now. The biggest issue is like, I read all these papers and I did all these tutorials, but how do I start? What project do I work on? Or where can I get a job? So I'm hoping this organization can be that this week to help you with that. So the agenda for today. So we're gonna have presentations from 3 of our members. So we have God Bennett. He's the creator of something called supersymmetric artificial neural network. He's not here yet, but he speaks a lot in the WhatsApp group, so you guys probably have seen his name in the group a lot. He posts a lot on like all the AI forums and like social media. Yeah. Did I still the name right? Oh, it's somewhere. Is it two M's? SAMM? Oh, okay. So somewhere from yeah, so he's gonna do a presentation of like AI and finance. I know some of you guys probably interested in seeing how AI can
Make a switch. But
make it make us rich. Yeah. Yeah, that should be interesting. And then Dimitri he's doing a presentation on using auto encoders for student processing. So he'll talk more about what's even an auto encoder. And they'll introduce themselves. And then after that, we can just have like open forum discussion on like different topics in AI. So we just back and forth. So the topics I choose are kind of like the topics that's supposed to engage in like a debate. So people have different opinions on these questions, like the term AGI, artificial general intelligence. Like, is that something that can actually be a reality, or is that a pipe dream? Will future AI? I think this is a topic that anybody, like whether or not you're a practitioner in the field, can probably provide an opinion on. Do you think it will provide more harm or good to humanity? A lot of people have watched stuff like Terminator and like, oh, obviously AI is gonna kill us. So that's easy. But then there's other people that maybe know more about the field that's like, no, it's actually gonna provide more good to humanity. So yeah, probably another topic we could talk about, will AI take all of our jobs? Or will we be okay? Will there be new jobs? Will AI maybe create new jobs? What's the ramifications if AI takes over a lot of jobs? Yeah, is it going to find some way to feed us, or make us happy, or so that we don't die? Or is it humanity's last great invention? Is it? So let's get right into it. So I don't think that is here right now. So we're gonna start off first presentation from Samario on its financial, using AI in finance. All right, guys. So please welcome Samario. So would you need the link? Zoom? Okay. You can
Discord chat. Yeah,
no, I think I put it in a WhatsApp.
yeah. Invite me to the WhatsApp.
Oh. Yeah, I found a bit.
Yeah.
Okay. Yeah.
No man. They'll meet you this. Just turn off the speed. No, just me. Just me. Just me. It should be able to share soon. Yeah.
All right. Good afternoon, everyone again. So a little bit about myself. I Yes, my name is Sam Argo. Unlike what much is my name was speaking out for it. Yes, so Sam Argo, I'm a data engineer, the marketing and data science program, and I'm also a quantitative researcher and trader. So I'll get into what that means in a little bit. So mainly other than work, school, I've worked in research in the financial space using AI, working more in the data science domain for creating strategies.
Sorry, go on top.
Yeah, for creating strategies and trying to make AI emerge, basically. That's the objective. So I'm studying a double major in computer science statistics. So I thought about the perfect major because having the statistical knowledge allows me to basically analyze large quantities of data and understand more from the data, basically. Yeah, so today I'll be talking about financial machine learning, data science, and just AI in um, the field of investments, right? And applications. I'll also be sharing a few projects that I've worked on, and hopefully you can incorporate some of those in your projects if this is something that you're actually interested in. So key points that I'm discussing discretionary trading. So understanding discretionary trading and how it differs from algorithmic or systematic trading. And then I'll be looking at data science approach to algorithmic trading and talking about the traditional rule-based system and go a bit more into time series analysis, statistics, where you can use statistics for trading and into the back testing aspect of things. And finally, I'll be looking at machine learning AI investments. Where we're talking about the financial machine learning, data pipeline, model creation, and model portfolio theory. All right, so let's dive right into it. So before I start, does anyone trade invest, money, buy stocks, crypto? Yeah. Nice. So I'm assuming everybody, most of us, probably be discretionary traders. Because we look at the market, we do some technical analysis, and based on our intuition, think up is going to go for Bitcoin is going to go, right? Yeah, so that's basically a discretionary trader. Warren Buffett's the discretionary trader. So a discretionary trader is one based the execution of trades on its personal feelings, intuition, and it's not most times backed by quantitative data. Right? So discretionary trading works for a lot of people, make millions. But the problem with discretionary trading is that traders sometimes, especially retail traders, succumb to managing emotions and realize that you have a lot of fear of missing out and greed and all this stuff. You have problems sticking to a plan. So if you say, all right, I'm going to go into a trade at X time, and you're that the trade's not going your way, it can become more chaos. So that's one problem with discretionary trading. And yeah, we use price action and technical analysis. And those things sometimes doesn't always work. Which and you think discretionary traders, they can analyze millions of data in such a small time. So which takes me to algorithmic trading. And this is more of a rule-based system with a set of predefined rules to invest based on certain conditions. Right? So this is what the program programs in the computer. So your algorithm might be simple. But for me, the moving average is basically taking the mean of the time series and say, all right, this is my algorithm. Whenever the price of Bitcoin crosses above the moving average, I'm going to buy because I'm expecting the price to go up. And vice versa, if it crosses below the moving average, I'm going to sell because I'm expecting the price to go down. That's an algorithm we just came up there. And that's basically the algorithm theory of trading. It does create a system, create a strategy, and a computer program that in the computer they expect it to run and see how it performs. So thing with this algorithm trading is consistent and it minimizes emotional interference with trades. There's no emotions in algorithms. The program set of rules. Sorry, the program one set of rules and it expects it to follow those rules all the time. Even if it doesn't work, it's going to follow the rules, right? And sometimes algorithm trading may be based on using indicators for these trades. So let's look at some statistics. according to Wall Street Journal, algorithmic trading accounted for 60 to 70% of overall US equity market trading. So this is something that traders are realizing that it works. And a lot of the institutional guys from Wall Street themselves have a lot of funds. Funds are basically quantitative traders. JP Morgan, Chase, a lot of these big investment institutions, they're using algorithmic trading. Prior to using them use discretionary trading or price action. So let's talk about the data science approach to algorithmic trading. We're looking at two specific approaches: so time series analysis and doing statistical checks. Right. So time series analysis is a specific way of analyzing sequence of data points collected over a particular interval of time. For example, interest rate every year, or the price of Bitcoin every day, hourly, or even per minute. Right? And as quantitative persons in the quantitative space, we want to analyze our data in such a way that we can make data-driven actions and insights from the data. So we can do time series forecasting by analyzing time series data or time series decomposition. So for time series forecasting, there are a few models. The most popular models I realized we used: the Ariba model, Paul Winter's method, and the Box-Jenkins method. This is mostly for like multivariate modeling analysis. Then you have the time series decomposition, which I'll be sharing a project that I worked on using this type of analysis, where you basically break down the time series, sharing the seasonality and the residuals. And then you have statistical checks. So when you get raw data, you want to check the raw data for certain anomalies and make decisions based on certain statistical evidence that you have in your time series. Right? For example, stationarity, where some time series, the property of the time series doesn't change over time. So you have a stationary series. You have autocorrelation, co-integration. A lot of institutions use co-integration statistics for peer-screening arbitrage modeling. And then the good old regression, so putting regression analysis, these are some important statistical checks you want to use with your time series data. Right. So how you create an algorithm trading strategy? I've tried to create this one, summarizing three steps, or four steps rather. Where step one is you create a hypothesis, similar to what I just mentioned here, the moving average hypothesis. All right, so you sit down, you analyze the market. Yes, I create my hypothesis. If this works, then I'm expecting this to happen. And then no, what you want to do, you don't want to take all your money and base off your hypothesis, you don't get the market. Second step is what you want to do is to create a system that backtests the person, or that backtests your hypothesis. So as a scientific person, you want to check if our hypothesis is true. All right, so step two, we create a system that gathers and clean data, because unstructured data is not going to do well for your model. So gather your data, clean the data preparation, and so on, and then you backtest your strategy or your model for at least 1 year. So you have sufficient data to test the strategy on. And then step three, you want to evaluate strategy using certain key metrics. For example, your win rate, how many times all the trades you place, how many trades are actually profitable. Right? Then look at what we call your alpha. So oftentimes we judge our performance of the model based on the return of a benchmark. For example, S&P 500 has sort of constant performance every year. So you want to see those your returns on the model beat that particular benchmark or so on. Then you have the Sharpe ratio, which checks the risk to reward ratio of the model, and then the drawdown. So how much I'm actually losing, how much I'm risking to make a profit. Then finally, once you evaluate the metrics, then you want to test the strategy for at least 30 days in a live environment. For example, a demo trading account. They test all your model performance in that sort of environment before you actually deploy the strategy. All right. Yeah, so that's basically traditional algorithm trading, the way you can implement a data science approach to algorithm trading. So now my final point, we're looking at financial machine learning and what are some advancements in financial machine learning AI. So a lot of persons use machine learning algorithms to detect fraud, trade activities, and provide financial advisory services like portfolio allocation and so on. So with financial machine learning, we can use these algorithms to forecast prices of the time series, for example, most popular ones are current neural network, for example, like LSTM model to predict the price of Bitcoin, whichever time series you're working with. We also use financial machine learning for pattern recognition, mainly like deep learning and anomalous detection in your time series. And sentiment analysis. I remember one day I was going to with Instagram and I followed Bloomberg. So I saw them post something saying the news headline was Tesla apparently ditched some, they closed on some factories in China, I believe. And this is obviously a bad thing. Look at it and say, no, it's kind of good. So I predicted that maybe it's possible, well, if you close on certain factories, then the production will decrease, right? If you don't have much factory up. And so I went ahead and said Tesla. And it turned out that price of Tesla actually went up and I made a profit. If you have an algorithm that does web scraping, analyze all those headlines, text, and then check whether it's positive or negative, you can actually implement good strategy to sell whenever the sentiment is negative or to buy whenever the sentiment is positive. And then modern portfolio theory for a lot of portfolio managers, especially on Wall Street or a lot of these institutions use machine learning and AI for modern portfolio theory to optimize the portfolio, which assets to invest in, and to select certain assets based on a user's, should I say, risk tolerance. Right? So created this pipeline that you can use, which I use on a regular. Where first thing is I want to have a system that gets the data. Yahoo Finance is one of the most popular ones you can get the data from. If you're using a stock broker that provides an API, you can simply connect to the API and get the data, right? So you have some data source that you're getting the data from, and you have the data, stock data plus return of the market and so on. So like financial data, the companies, assets, and all of those, those profit per earning ratio and all this stuff, right? And then financial news, like I just mentioned, like the web scraping, the data processing, and natural language processing, and you can use a model for sentiment analysis, combine all that data into one final data set, right? And then you split it like any other machine learning model, creating a split the data into train and test data, and then you build a model, evaluate a model, and you want to plot how it performed on the time series. So the points will actually bought the stock, sell the stock, and what it predicted versus the actual results. So you can use a simple model to create a financial system that trades for you. All right, so here I created 4 steps where you can build out machine learning strategy. All right, so step 1 is to gather the data from some data source, right? Some data sources may not be data, so you have to do some data processing, but ones are like Yahoo Finance, Google, or Alpha. And step 2 is that you want to, most of the time we spend in step 2. Cleaning the data, preparing the data, checking for non-value, but we want to make sure that the data is clean for example. Unclean data or key tracking your model in so most of the time, check for statistical, check for organization, all the stuff, right? And then step 3 now is where you check for importance and you can go to the methods to feature importance and instruction. And the chain test split, normalize the data, you put in a model, for example, I'm using an LSTM model here. Then your predictions, so you use a model for your predictions, and step 4, similar to your algorithmic trading. step four, where you evaluate your model basically and test the strategy before deploy. Yeah, and some further advances in financial machine learning AI. One further advance is Monte Carlo simulation for risk management and option pricing. That's one thing that a lot of researchers are looking into. Second thing is quantum finance theory, which I'm actually planning to do my PhD research in, which incorporates quantum machine learning, quantum AI, and the concept of quantum finance and economics. And step three, alternative data. Lots of institutions are actually using this now, like satellite image recognition. I remember I heard a story where this popular hedge fund, what they did was they used satellite images to look into like parking lot for Walmart, and when you go for a certain quarter, if these a lot of customers were there, cars or the cars, the parking lot, you can estimate that sales will go for that particular quarter. And so they use that to base investment off. Yeah, so thanks for listening. So that's to connect to me. Connect with me, then there's my Instagram, LinkedIn, email. I'm going to share a few projects, two in particular that I've been working on.
Before you continue, anyone have any question? That's why they
Sure. No questions?
Yeah. I mean, have you done any sort of, I guess, financial machine learning, like, so?
Yeah. Yes, I have. Well, most of the models that I've created, they can work in a wide range of assets or derivatives that we use.
Have you found any difference between trading that versus regular assets, like crypto versus stocks?
Yes, sometimes not all assets work with a certain model. So you might find a model that works well with Bitcoin, but it doesn't work with Tesla. Yeah, so yeah, I've actually seen that. So this is a seasonality model. So remember, I was talking about seasonality. So what I did here, I imported some packages that I use. So Wire Finance is where I get my data, and technical analysis library and some important libraries that I use here. Then I create a function to get the data here. You can see. Yeah, and here are some assets that I define. So I get the data. This is the head of the data. And yeah, I created a model called Decompose, which decompose the seasonal. So I take the trend, the seasonal decomposition, and the residual. And I did some additional calculation, finding the max seasonality degree, minimum seasonality degree. And I'll plot that for you and show you an example of what it looks like. So this is the price of, I believe, Tesla over time, right? In the green. And then we have, we decompose the trend of Tesla. So decomposing the trend might be useful for your model, where it reduces a lot of this noise in the fluctuation of the time series and give you a smoother trend, show you the direction of which the market is going, basically. And then it gives us the seasonal decomposition and the residuals, or somewhat the noise of the time series. Here's a printed out some statistics.
Can you actually put share screen for that? It's only sharing sample.
Okay. Share. Yes. Good.
Yeah, you can just continue.
All right. So I just look at some statistics of the time series, look for outliers in my time series, check for correlation, and then I'll just show you. So I'm looking at modeling the seasonality with the price of the asset I'm trying to trade. So my strategy is, if so seasonal basically checking how your time series changes over seasons, or it changes, for example, interest rates per quarter or per year, in the summer, in the winter, so on and so forth. So I'm saying whenever I take the maximum price, the maximum seasonality, and the minimum seasonality, I'm saying whenever the seasonality is below a certain threshold, I'm going to buy. If it's above a certain threshold, I'm going to sell. But it's somewhat of a mini version strategy. I'm going to show you the performance of this. So here I just implemented the strategy. So it's my buy signal. Like I said, I implemented the RSI as well, which checks for, it's called the relative strength index, which checks for overbought and oversold areas of the time series. Yeah, so here are my signals, my buy signal, my sell signal, and I'll show you the performance of it. So this is how the model will perform from 2019 to the current day here. As you can see, a few fluctuations are down, but generally long-term, profitable strategy. And this is what the strategy looks like compared to a benchmark. My strategy is the orange benchmark return. So you can see outperforms the benchmark. And I'm showing you the buy points and sell points. But you can see here, actually buy some good points, the lows and the highs. Some points actually bought, for example, here, you see a drawdown, but generally, it actually enters the trades at some good points, for example, here, to see the market goes higher, and you sell here, market goes low, and so on. And yes, so that's basically one strategy I implemented using data science statistics. And final one I want to show you is a deep learning one for classification. Right. So here I just get my data, calculated some returns, the volatility of data, and remove missing values, split my data into train and test, and standardize my data. So this is deep learning classification. So I created my classifier, my networks, and I'll just basically training model already. So I'm not going to go over training it again. And output my predictions. So you can see the benchmark compared to the strategy using a deep learning classification. I'm going to show you the regression, which doesn't perform so well.
Question just by between your thought.
What's the accuracy?
Accuracy, I can actually predict the accuracy. This will train relatively fast. So right. So 64% accurate. 64% accuracy. Yeah. Just the returns, compare returns and the volatility. Returns and the volatility. Along with the mean returns as well.
So I click on returns.
Yes, of the asset. Regression task. I'm going to show you a regression. Or regression would perform.
It charts for USB.
I think so. Yeah, should. But actually, should be come back. Yeah, so if I actually use a regressor for the return of the asset, realize it doesn't perform as well as the classification.
You're monitoring the
the benchmark is in the green percentages of the group. Yeah, you can see they actually had a sharp ratio. A good sharp ratio is one with one regulator. And you can see the sharp ratio is much lower, which measures the risk to reward compared to sharp ratio, which I had here, 1.5. With maximum drawdown at 31%. So yeah, So this is basically what I spend most of my time working on, researching and creating strategies to model the market.
I have two questions. One, first one is a statement. Code look clean, that's good. Second, you're going to like open source that so we can improve it.
Yeah, sure, why not, sure.
Okay.
Yeah, sure. So, any other questions, suggestions? 64.
No. Just take it.
So are you asking if there is anything unique to what I did? Like,
Asking if you not great, but yeah, exactly.
oh, I don't know. So what I did was implement the knowledge that I learned. So obviously persons have done this before.
No problem.
Yeah.
That's a change.
Oh, I see.
So
Yeah,
thank you. Nice something process.
yeah.
But that
Yeah, true. Most of the strategies they would keep that private, so you wouldn't even know.
so we told
Yeah. And there's a lot more that can be done here to increase the accuracy of the model. But this is just a general application. Yes, I have. But particularly with this seasonality, particularly, yeah, this is much more of the profitable strategy than a deep learning strategy.
I guess performance.
Yes. Like you've seen here, I didn't use any deep learning seasonal, they just the statistics alone and figure that performs better than deep learning. So I believe more work can be done with that particular project to optimize the profit for that.
You said specific
I created my own bucket. But for this one, I'm actually using Portfolio, which the library created by I think, Zipline. Yeah, so this is one that's imported for this one. Yeah. So yeah, that's it for my presentation. Thank you very much for listening.
Yeah, what's up?
Recording in progress.
Must say HMI port. Yeah. HMI port shit. Alright, so you need to run working leads. I'm very interested in that. You're not interested for quite a while. Eventually, you're gonna ask you questions. Monitor will complete the exam. So I've tried out this trading thing as well. I've done some experiments and I'm really working on it. But I have some knowledge in it. And I want to show you guys today an experiment I've been doing now. Talking coders and how we can use them to measure sequence data. So let's get started. So what is an autoencoder? The main thing to note about an autoencoder is the way it processes data. It has two parts to it, an encoder and decoder. The purpose of the encoder is to encode information, which means reduce the dimension of the information to a smaller amount. And then decoder is exactly the opposite. It increases the dimension of the information to the larger. So you can see what's happening here. This is a direct demonstration of what an autoencoder will look like. So these consider these as data points, and these as the model. So these are the input points, and these are output points. So these could be anything you want to put input interface, could be color information, could be audio, financial information if I want to do that, represent images, of course I can do images. So it will get smaller and smaller until it get to a point that called the latent representation. That's just how the data represents, how the data is represented. Imagine it's similar to the compressing information with into a zip folder essentially. But the model itself is decided how the information is compressed down to that small representation. So it actually learns as it goes and finds an algorithm essential to compress information. That's encoder. And then decoder does the exact opposite, which is to try to decompress the information and put it back into the form it was before essentially. That's usually how it is. It's not obvious upon hearing that what exactly is the use of an autoencoder, but we'll get back to that. But I want to show you guys some more a bit better explanation of what they can use autoencoders. So this for example is one of the things you can do with an autoencoder. So you could train it to turn lower resolution images into higher resolution. Because what it's doing is essentially adding information that wasn't there before. It's coming up with information that would make sense to put in that space by itself, based on the data that it's generated. So that's a great example. Oh yes, and also I think Samara mentioned before anomaly detection and also image dehumanizing. That's something you do with autoencoders. But the most important thing you can do with the autoencoder is called unsupervised learning. Unsupervised learning, the purpose of that is to essentially make use of all the data that you can find about a project section. The task agent. So imagine if I wanted to teach a model about how the world works, you have to feed all the information you could find. So imagine you wanted to teach about images. You could literally pump all the images into an autoencoder without actually labeling the data in different ways, for example, to classify it. Because all I wanted to do is to get a general understanding of what is in the data, the general structure of the data. We can put all that information, or try to put all that information into an autoencoder. So that's the main purpose of it, or the most useful part of it. There are other types of autoencoders. They have like variation autoencoders. Those are interesting, but that's a big topic. Like, so they can use those essentially when you create an autoencoder. You only take the back part, which is the decoder off, and use that to essentially generate images. New forms of data, similar to what we do with GANs, which are generative models. So yeah, you can use autoencoder for that. You can combine them with GANs as well to just make more fancy models. So you tend to use this in some of the more new models that we're using. For example, use VQ GAN a lot in some of the latest new generation models. So those are interesting. But they can't get into that. So this is a good example of what we can do with an autoencoder, right? So if you be in machine learning for any amount of time, you know about this any data set, where you just a set of numbers, 1 to 9, 0 to 9. So the purpose here is to simply embed the information into the autoencoder, right? So it'll feed all the endless digits from one side and try to make it reconstruct them on the other side. As you can see, the reconstruction on this side is very similar to this, but it's not perfect because what it's done is it's learned the essential parts of the information and pass it down here and try to reconstruct it from a small representation. So that's what they're doing for the autoencoder. Right? Next, we can move on to sequences. Why am I talking about sequences? Why are sequences important? Okay. So we have different types of information that we can try to feed to machine learning models. So, for example, video information, audio information, text information, and of course, we have the financial data that we can try to feed. If you guys remember anything that I said here today, it should be this. From the point of view of the machine learning model, these are all essentially a very similar task. Right? What is similar about them is that they are time dependent. Information in any given point is dependent on what's happened before in another given point in the information. So, for example, words are speaking. Obviously, you need to know what a person said 2 seconds ago to actually make sense of what he's saying right now. Right? So, this is something that's very important. So, effectively, humans, this is a very big difference between how machine learning models are trained today and how humans are. We effectively train them on images, one image by after another image. And those images might not have anything to do with each other. But in reality, when you're looking at, when you are experiencing the world, you experience the world as a stream of information, sound and images and stuff like that, right? You read as a sequence of information. So that's why sequences are important. If you want to really create general AI, it needs to have something that can process things in sequences. That's probably necessary if you want it to get actually experience similar to how we experience the world. That can make sense of it. It's not needs to process the sequences. So remember, all these types of information from the perspective of machine learning are very similar. So how we normally process sequences in machine learning is with RNNs, or RNNs were the first. We're going to have LSTM and GRUs. So what these try to do is they process each item in the sequence one by one. This leads to them being very slow. They process them one by one. As a result of that, they can't actually take advantage of parallelization. Parallelization is what the purpose of GPUs and why machine learning has actually taken off recently, because we have GPUs and they can process all this information together in one go essentially instead of doing it one by one. And just having, if you guys have been in this far, you know that it's time that it takes models to train. If you're working with large data sets, that can actually be a very huge hindrance when it comes to training these models. So if you have to wait too long for one to train, it's going to cost too much, and effectively the project actually just can't work with it. Yeah, no parallelization or anything. So you can see how they work, but like, we're not going to get too deep into how they work. I mentioned the most important parts already. So lately, I mean, if you've been into this field again, you've heard about transformers, or how fancy transformers are. And they are actually way faster than LSTMs and iron networks. So normally we use them for processing words, of course, words are sequences, and they are able to do this because they use attention. Attention is something that is a mechanism that allows the network to pay attention to each of the given words in context, essentially, instead of processing them one by one. So the huge advantage, oh yes, I forgot to mention this. The main issue with all these sequence processing applications is that they tend to not be able to pay attention to or process very long sequences. There's simply a limitation as to how much information we can fit at one time into a network. And given the architecture, different architectures can fit different amounts of times. So this is the one improvement that was made with the transformer. And also the other thing, you can just process for far longer sequences. This is important for audio data, image data, not image data, video data, and of course, for much others. But I guess we can talk about vision transformers. Vision transformers, all it is split up image into different pieces and process it and flatten it into tokens that look similar to how the words look when you process it to a transformer. So vision transformers are very similar to normal transformers. It's just that you change down the inputs of the images first, differently than how it goes into words, because it's a fundamental different. They have to just reformat the images first before you can put them into a transformer. And of course, they can use vision transformers for processing audio, processing video, but it tends to be a bit more difficult to work with transformers. They're very confused, but I guess over time we learn better how to work with transformers. So here's a look at now the problem that I've been trying to work for a while. So it's moving image. So we want to start at a very small fundamental level. So if you know what MS, you know what MS is. MS is just a set of digits, 6,000 digits. So moving MS is as a data set derived from this. So we have a number of digits and they're moving around in a sequence. So for example, you have 20 images essentially in a sequence, and 2 digits move, and it's a 64 by 64 frame. So that's how it's different from just image alone, because it's very time dependent. You have to pay attention to it. Normally, you would try to solve this by using something like a convolutional LSTM because it's image data. So you actually use convolutional network to solve it. And let me just give you guys a good look at how it's normal. You guys should really check this out. This is the Keras code exam. You should really look at this. They do all kinds of stuff in here. They can the computer vision, NLP, everything. You have a lot of examples of how to implement all of this stuff inside Keras, essentially. Whole lot of stuff, experiments. Like you should really fool around in here because there's a whole lot of knowledge. Like they just have the code ready for you to run essentially and learn. I need to learn from it. Honestly, this is where you should be if you want to actually get a good understanding of machine learning. Because they're implementing real code that is in research by researchers. So this is how it typically looks when I try to construct something out of a convolutional LSTM. But so what I was doing was I was fooling around with autoencoders to try to essentially do this. Normally you wouldn't even think about using autoencoder because it's a sequence. But actually I was thinking about it. Yeah. So here is some of the code. I run it earlier today, so yeah, it really took me like a few hours to train. Yeah, so there's no way I could do that thing and just have it running for you guys for the whole. So yeah, let's just start here. Okay, so did I explain what we're trying to do exactly? So what it is a series of 20 images, and we're trying to predict essentially the next image. So what's happening right here is that the network is trying to predict what's happening in the future. But of course, its construction of what's going to happen in the future is not very, very clear because there are it doesn't really, it's not really able to reconstruct it perfectly, essentially. All it really needs to do is put this thing over here and just create a perfect representation, perfectly clone this right here with prediction. So this goes in and this comes in. So you just wanted to get the all data, the previous experiment and prediction. So it doesn't make sense. Go through the code. We just have our imports here, normal stuff, TensorFlow, Keras, yeah, NumPy, stuff like that. Then right here, I would need loading the images and organizing them. 10,000 images. Yeah, that's because of the size of the whole data set. Okay, yeah. So have there, we split data set right there, and that's what it looks like, right? So the training data is 9,000 images, 19 by 64 by 64 by 1. Yeah, did I get that? So it's 9,000 videos essentially. Each of them are 19 frames long, and the size of the image is 64 by 64. And I only have one channel, one color channel that is black and white. So that's what we're doing right here. So it's very important to keep track of these dimensions right there, because these dimensions are very important. If machine learning, if we could build GPUs that would process essentially some huge amounts of GPU memory, we would have to put in those GPUs. I could process essentially all we have to do is just plug this information and feed it to the GPU, and it will just come out and probably give great results at the time. But in reality, when you're trying to process these sequences, the GPU just cannot handle do it the information at the time. If you try to plug this, it's work out with some gigantic number, essentially. 19 times 64 times 64. That doesn't sound like much, but I think I would also work out something like some 70-some thousand or something like that. So that's the number of nodes you have to have in one day for it to be processed and something like that. Yeah, and that's the So yeah, we're showing up here what the data, what one of the examples of the input would look like. So this will be one thing. So you can see it's going frame by frame, but it's a moving thing just like over here. So what we're trying to do is reconstruct this, but we're not going to use transformers, we're not going to use LSTMs, essential things. So sorry that the code looks like this, but yeah, I guess it would be better for us to look at this right here to get an idea of what's happening. What's happening with the output encoder. So this is the input layer. So this is what's happening. So none right here just describe the amount of the batch size. You don't have to worry about that. But one of the input size is essentially 19 by 64 by 64. So that's 19 frames, 64 by 64 by 1. So what happens next is that we're running through a convolutional LSTM, convolutional layer, but with time distributed. What the time distributed layer does is it applies the same convolutional function, essentially everything along this line. So you notice that 64 it becomes 32, and then this becomes 64. That's what generally happens when you do convolution. And then yeah, we do a batch normalization and then iterate. That's just how data performance. That's just how these networks work. You just have to batch norm them every time you're working with images. I guess I'm biased when it comes to working. So remember I said before that you don't need to use it to process images. You don't need to use images essentially. You could use this for audio information or any other type of sequence information when you think about it. So that's the realization that I came to where I tried to make this experiment. So yeah, so you notice it goes from 32, then it goes down to 16, and it still stays at 19. So what we actually do is reducing the size of the image from 64 by 64 down to a smaller and smaller and smaller one, to the point where it gets to 19 by 8 by 8 by 8, and then we reduce this number over here by 2. So this when I multiply this up, it's actually a small enough number that we can build we can actually flatten it and turn it into just fit into a density. You can actually build this whole thing without this density, but the performance wouldn't be aside. I know this, but that's actually a part of the design that actually came up first, and then I realized we could actually do it without this in here. But so something I want you guys to notice is that the parameter amount for this network is 6-point-something million, right? And right here we have 5.9 million. So the majority of the network is actually right here where we decided to put a density in between the convolution there. So what we're actually doing, right, is encoder that goes down like this and makes the information smaller. Then we'll feed it to what very wide 2000, 2432 neurons dense network. Then we feed it, then we cross it, then we essentially reshape it back again into the shape that it came in us. And I will try to then we deconvolve. You guys understand deconvolution? That's essentially the opposite of convolution. We make the information bigger and bigger again until it. Okay. Okay. Yeah, the information bigger. But that's big for the side again. Makes bigger and bigger and to get back essentially this on your side. So when in a flash network, that's what that you get is it's completely nice when you try to feed sensible information into it. That will be an image. So you try to feed the image into it and the output will look something like this. So that's before training. And then we train it for how long this took me to train this morning. Yeah, train for a while. And we actually get to test it now down here. So what we're looking for is to see the predictions being slightly ahead. So we want to see the predictions being actually working as in being slightly ahead in the future, and also looking very similar to this. And believe it or not, that's exactly what we see. So the point of this whole experiment is to show that you don't actually need LSTMs or transformers to do time series prediction. You can just do it with the offering. It's a thing. So you can see it looks like this. If you look at, I guess these are not like this, but let me try. So we have run, it just like a piece of data. Don't want to see this right here, this right here. It tries to reconstruct it. Oh, wait, no, wait. Again. So it looks like the 7 and 5, but it should be slightly different because it's closer to this one right here than actually this one right here. So if you notice how this one right here, this is the actual input, and then this is the output. This is the first output. So it's actually predicting. You notice how this actually looks closer to this than this. That's because it's predicting how the you can see the reconstruction is not perfect. So it was a prediction versus the original input. And then this is the same thing. I guess we can just compare randomly select one and then see how the output looks. Yeah, one time. Yeah. So you actually put in 20 at a time and output back 20 at a time. So it's actually predicting one time. So you could imagine using this for time series, try to do it with financial data. I could try to my next experiment will be trying to use this for probably some audio, like you can do audio generation from speech text or something like that, or just some text generation, some text to audio or something like that. So it's just sequence information to sequence information. So if I think about it like that, they don't actually need the fancy transformer to fix the issue. Okay, I guess that's it. Any questions? So this when it comes to autoencoders, they don't have accuracy. The only thing you have to work with is loss, and loss is always a relative value. So the loss, I guess it's the closer to zero it is, the better it is. The better the reconstructions. So it's actually you get a better idea of how it's going to perform just by looking at it than from looking at the last value. The last value is 10 and just a number that is right. So you can say the loss just to 0.0, some 0.00 something. I guess it's a very low number. Yeah. It's not zero, but yeah, it's really a decent construction. So that this 0.31 relates to this quality reconstruction. So it's not classification, so it's more of a regression.
Right, so I'm at the AI first. Thank you for this topic. Probably able to autoencoders, big blur images, not blurry.
Yeah, exactly.
And that's unsupervised learning, right?
Yeah, that's unsupervised. Or you can call it self-supervised. No, you do train it. You train it, you give it the blur images as input, and the output will try to reconstruct with the actual image. Okay. So it actually hallucinates or imagines what image is supposed to look like. So it's not going to create a perfect reconstruction image, but it's going to create something that it thinks the image will actually look like.
And the train on data that shows comparison to the blur.
Exactly. So you could have the proper images and it just create blurred images from it by corrupting it, or some kind of process for corrupting it. That's that very similar to just denoise it. So that to remove the blurriness and try to reconstruct it. No more questions. Wait, could try that. I could try to. Text to text, that would be similar to what GPT is trying to do.
So, so we're reporting a transformation with
But my number four transformation method.
like essentially all the data decomposes down the like small frequency from the original frequency. Maybe because of noise.
Yeah. Great for me for actually looking out.
Prevention songs carry to but to a different place. So call it now domain and then chance because how we computer that calculate it like much easier to explore just how to calculate.
Yeah, it actually makes more sense if I can do it with a program, it doesn't make sense to do it because that's gonna be more accurate than the reconstruction from the end. That way, if it can be mathematical, there's no really any point in doing it with that. And do it with that equation because what the neural network is trying to approximate an equation that relates to two data sets. So if you already have an equation that perfectly describes the relationship, there's no point in using anything.
Long term, know when to apply deep learning and machine learning.
Well, that's a very subjective question. When to apply? Well, I guess when you apply it, when you have a whole lot of data, but you don't actually know the answer. I guess that's when you apply. So it's when you're always trying to find a function that's a relationship between the data, the input and the output. So that's what they're always trying to do. If you don't know the relationship, then you can try to apply that data. Yeah. Human I feel like we're almost there now. I feel like the transformer is actually good enough to get there. I feel like transformer is actually good enough to get there. But the challenge is actually teaching it how we actually teach it to interact with human level types of interaction. Because it's actually people of understanding concepts that we ourselves understand and know, right? Like shapes and all sorts we need for actual reading intelligence. So if I want to have the proper way of thinking, I think that's where they are. Properly training a transformer GPT or getting a big enough one that can actually, but training technique is really, I think, a challenge with genetic. Training technique can probably maybe not information about the power of the machine that we're training.
You guys,
Lunchtime.
No. Oh, so from then, those stuff. Yeah.
No, this time is from last year. So for example,
This guy is actually,
yeah.
actually consider that. It's a soul, it's a Stevie.
Yeah. It's coming up extra operations. I know why.
Let's go back, yeah. Camera is camera is before.
That's sure. Oh. But yeah. Not sure why it's not that. Like additional usage to the computer nowadays and just keep the YouTube while
Yeah.
it works.
Wait, is it safe to go in your YouTube?
oh no. You are going to present on somebody else. Oh, present on. But each service.
Well, you know,
Yes. Well, take care of it.
This is the nice. Oh, you need to log in. Oh, yeah. Okay. This one? Oh, it's cool. Free. So how do I have to oh, okay. On the song,
Just mill it. Just just mill a squeeze.
yeah.
One place. One place.
Almost naturally.
First month.
So I mean, break the place. You know, I was talking about the players, but the social media. It's
What? To go where? You're not shooting.
yeah.
Only those.
What kind of chicken? What kind of pizza? Second chicken? What? Church. Next.
It's so much smaller than I like it. The only thing that should be connected to is each other. Inside. Also,
Jordan, stop this screen share. No. Oh, okay. Matthew, stop this screen share. Doesn't matter. No, sure. Oh yeah, I forgot to stop it. Oh, Jordan is supposed to know keep by all you know.
It's just
QWERTY keyboard. Doesn't matter.
let's see if you want.
Very interesting.
Right. Yeah, so what do you do? One line, but we're not necessarily basically keep for decision.
Yeah.
Yeah. Page but is a it's okay. So I finish second. What do you want
Oh.
That's pretty much
No, this curious about tabs.
oh no. What's in one of the cars? That's it's maybe one of it's not the Jamaican Islam. You know that's the part. Are because the ego structure and being a number, I would say not Jamaica is currently people.
Stop.
Okay.
Stop.
No, you can start. You want to start. I think you have to.
Instead, I can look up on page like English, here, basically, research team and stuff like that.
The system like AlphaGo that could beat Go, but couldn't walk. The mathematician I.J. Good, back in the mid-1960s, introduced what he called the intelligence explosion, which in essence was the same as the concept that Werner Vinge later introduced and Ray Kurzweil adopted and called the technological singularity. What I.J. Good said was the first intelligent machine will be the last invention that humanity needs to make. Now, in the 1960s, the difference between narrow AI and AGI wasn't that clear, and I.J. Good wasn't thinking about a system like AlphaGo that could beat Go, but couldn't walk down the street or add 5 plus 5. In the modern vernacular, what we can say is the first human-level AGI, the first human-level artificial general intelligence, will be the last invention that humanity needs to make. And the reason for that is once you get a human-level AGI,
So I think for team most of Yet smarter machines can make 10,000 copies of itself, some of which are much more intelligent than
the original. And once the first human level AGI has created the second one, which is smarter than itself, well, that second one will be even better at AI programming and hardware. The mathematician I.J. Good, back in the mid 1960s, introduced what he called the intelligence explosion.
Alright, guys, let's go, let's go. Ready?
Great Kurzweil adopted called the technological singularity. What I.J. Good said was the first
Send it on, please.
intelligent machine will be the last invention. The mathematician
Alright, you ask a question, ask questions. Who here knows what human and AI? Who knows what human and AI is? Artificial intelligence. Discriminatory, what is it?
No.
Human.
it is AI has the same level of intelligence as humans.
Yeah, that sounds good.
I.J. Good, back in the mid 1960s, introduced what he called the intelligence explosion, which in essence was the same as the concept that Werner Vinge later introduced and Ray Kurzweil adopted and called the technological singularity. What I.J. Good said was the first intelligent machine will be the last invention that humanity needs to make. Now, in the 1960s, the difference between narrow AI and AGI wasn't that clear, and I.J. Good wasn't thinking about a system like AlphaGo that could beat Go but couldn't walk down the street or add 5 plus 5. In the modern vernacular, what we can say is the first human level AGI, the first human level artificial general intelligence will be the last invention that humanity needs to make. And the reason for that is once you get a human level AGI, you can teach this human level AGI math and programming and AI theory and cognitive science and neuroscience. This human level AGI can then reprogram itself, and it can modify its own mind, and it can make itself into a yet smarter machine. It can make 10,000 copies of itself, some of which are much more intelligent than the original. And once the first human level AGI has created the second one, which is smarter than itself, well, that second one will be even better at AI programming and hardware design and cognitive science and so forth, and we'll be able to create the third human level AGI, which by now will be well beyond human level. So it seems that it's going to be a laborious path to get to the first human level AGI.
course.
It's a quick YouTube video of what?
For just $67, you can make as many videos as you want, and you never need to pick up a camera or.
Yeah. So a quick demo of what CryptoSynth is. It's basically a solution on NFT tool and blockchain. It's basically the first NFT you can talk to, interact with. I made some money, not a lot, but money has been made for me. So basically, who here is familiar with Blender 3D? Blender 3D.
Blender.
Yeah. So basically what I did is to merge convolutional system, the language system, merge that into Blender 3D, and after that as a product, which you see here, sold on the blockchain.
So you model this by yourself?
So how the 3D human are artificial. So the first step is to generate 3D photos of the human. And the second step is to take that image, or artificial image, and generate a 3D being, and then incorporate the language model into the 3D being. So that's what being looks like. This was actually inspired by my sister. She was undergoing chemotherapy. So I basically experienced of the CryptoSynth and my late sister. All right, so let me show you the next example. One more example. The next example, we have applied AI. I have another car, apart from the black one. What I did was to apply. This was my vision of a low footprint conversational agent in a vehicle. So this was my idea of making a vehicle with a friend, so to speak, and an assistant as well. So I managed to install what I call XIN, developed for the X generation Civic or the 1010 Civic. This is a conversational agent which can interact by voice, and this uses IBM's cloud infrastructure and their conversation system to enable this.
Hello, Honda Civic owner. Let's talk.
Hello.
Good day.
What is your real name?
I was born as an eye in IBM's cloud infrastructure, and my real name is simply Synth.
Yeah, so you get the idea of that by now. So one other application of AI I was interested in is healthcare. So why am I bringing this up now? This is actually the world's first known open source solution for COVID-19 diagnosis, involving taking as inputs X-ray images and producing a prediction on whether that signifies COVID or not. So it's a quick snapshot of the interface. And in the general AI world, what you have a sort of strategy that we employ. So I talk about this in my AI diploma that I lecture in. I call it the RED policy, or rapid experimentation design policy, where you observe a landscape of solutions. Suppose you want to solve a problem of COVID-19 diagnosis, for example. What I did was read and see that, in fact, COVID-19 was a form of pneumonia, and therefore we could look at current solutions that the pneumonia detection. Of course, with COVID, I found that the prediction was, without training on COVID-19 specific X-ray scans, I didn't achieve good accuracy. But after training and whatever sparse data was available back then, I achieved up to 87% sensitivity, which is about 70-something% accuracy and so on. But the point is that machine learning is helpful to identify a model that someone solves a problem, but don't fall in love with that model. Don't stick to that model. We do a quick iteration, as a colleague pointed out here, that we don't spend a long time, for example, to train one model. We see a model has a poor accuracy from the very start, and we can see that sometime in the notebook, for example, we can see, well, in training model, we can see the accuracy from the last run. What it is, just identify a model with good accuracy, and not just good accuracy, but with sensitivity, because sometimes a model can have good accuracy and have very poor sensitivity, for example, in healthcare applications. So you find a good model, you iterate over that, and you build a solution on top of that. So that's a form of rapid iteration that we see, you actually observe happening in the AI world. Yeah, so that's one more thing I wanted to discuss is my introduction of something called Why AI. It's a concept of mine involving establishing a company and helping to develop our public world with multiple AGIs. So you have a bunch of AGI companies already, but there's not, to my knowledge, any one company that is focused on building out a public planet with AGIs. So my research, and I don't have a solution for AGI, at least not a whole solution, but what I seek to do is contribute fundamental models to AGI. So by fundamental model, look at DeepMind's recent model. You know what the model was called? Last month, the model that Gato, so exactly. DeepMind Gato, where I think that's the best approximation of AGI to date. We have one model that was over 600 tasks across multiple modalities, as my colleague indicated today. So including images, videos, prior perception, and robot control points. So multiple modalities, a single unit, a single machine or solution. So that solution now consists of a particular grade of deep learning model. Think of COVID-19 diagnosis and whereby you have convolutional neural networks. It was popularized by Jan LeCun, professor of Facebook AI research now, and co-winner of the Turing Award, which is like a Nobel Prize in Physics for computer science. So that convolutional neural network, you can see how impactful that has become today. So what I see in creating this type of company is to contribute what we call foundational models or core models, which form a reasonably core part of the entire architecture. As I said, I don't have a solution, the entire roadmap to AGI, but we approximate that these foundational models may be quite relevant in that space. So one type of model I proposed was something called a supersymmetric artificial neural network. Just Google that. So for all who are not really AI people, to break it down reasonably, so all of AI now concerns, it's a bunch of numbers. So when you look at an AI algorithm, like the one pertaining to any of my colleagues just now, when these machine learning algorithms learn to do a task, You're just using a bunch of numbers to represent input space, and predictions themselves are yet another bunch of numbers. So machine learning, from the history of machine learning, we use a variety of numbers and structures to do our task. So, for example, the old days of the perception, there are simpler models. We use things that look like integers. Integers we can't really signify the input space, or like a cat, a picture of a cat, with much accuracy. But as we move through, we use more and more complicated numbers and structures. We started to see a growth in accuracy of our models. Eventually, we started to use things like convolutional neural networks or RNA, which is a form of deep learning model. So convolution would involve real numbers and convolution and those numbers. So what supersymmetric artificial neural network proposes is that instead of using, so technically, convolutional neural networks, like using unitary neural networks, involve something called unitary matrices. And if you go back to the perception, like the simpler numbers, involve use of something like that look like special orthogonal matrices, or something like that. So as we progress through neural network, we use special orthogonal matrices, we use unitary matrices. So what the supersymmetric neural network proposes now is that we use super unitary compatible matrices. So it just yet another form of doing machine learning, i.e. using more complicated structures to do some tasks. So that's what my proposal, I can look at it. So let me just quickly summarize it here. The quick summary I provided. So we can see it here. So we consider our structures, they're not really susceptible to or amenable to gradient descent, which is, remember again, machine learning concerns a bunch of numbers being manipulated and altered. So basically, this is the landscape of the variety of type of structures that are used throughout machine learning. So that's basically it. So the summary is that AGI is likely emerging by around 2029, 2030. And if we don't enable ourselves with some skill sets irrelevant to that era, we will likely see the wealth gap being biased in the direction of people or corporations who utilize these technologies, build out some of these technologies. So that's basically it. Yeah.
Any questions?
Let's go. No problem. That means you can repeat that. Maybe this better human, like Einstein did. Not really like little one those people don't want. Although the way is not so bad. If I work exam. You know the work at times like prisoners and so on. Want to find good exam.
But I think that's simply for
But you kind of smart though, so.
into the discussion. So I guess an open discussion. What do you guys think? Do you guys think humans will at some point create machines that are less intelligent or do more intelligent than humans? Or is that was a momentary that was what do you guys think?
I mean, yeah, maybe 20 years, we see we're actually close to right the parts. I mentioned. But it doesn't also be a introduction so we're out of food, we need something pretty
Protein, holding. Yeah, and I said the same company who made AlphaFold DeepMind It produces the same thing I was talking about, Gato, where one model is good at multiple tasks, including protein folding, if I'm not mistaken. So that was a protein folding task, but the Gato is a bit more, quite more general. So not only can it do that task, but a wide array of tasks. That's the first example of a generalist model. Not quite agile, but generalist today from knowledge.
So, you can just like, stuff like,
yeah, in fact, Gato uses a flavor or was inspired by large language models like GPT-3. So they're actually inspired by LLM, large language models.
Yeah. You made reference to SIM.
Yeah, SIM.
SIM.
Yeah, like
So-
synthetic.
Yeah, so you made also another reference to the blockchain. And how would the AGI actually impact on blockchain?
I'm not quite certain, but Ben Gorson, the same man, actually created something called SingularityNet. It's intended to work to develop AGI and talent with blockchain. I'm not sure about that part. So I had to develop a product that's sold on blockchain. I didn't have any part in actually constructing any of the blockchain pipeline. So I just built a product and uploaded it for sale on the blockchain. But as I say, you can look at SingularityNet. And just think anywhere where human interaction or human activity or human thinking, it's like to be impacted. But think about any conflict task, driving, teaching, any conflict task you can imagine.
And what about sentimental analysis?
That's involved as well.
What are the kind of things that we like take over? Most of research I do sentimental analysis is pretty much struggle at the moment because one robotic responses, robotic voice, not capturing empathy, sympathy, and all those emotions. So, for example, I think McDonald's they are those robots that can come to serve you and then ask you for things. And then robotic voice. Of course, people are making fun of it and so forth, but at the end of the day, being customers and understanding.
Question, would you
Yeah.
build a website for a major brand with more than 200 million users?
The progress with the assistant all seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
If you notice, that sounds very human. Well, so it's very human. But you're right, there are problems with that.
Okay. So we all know Google is great, but not necessarily example, Stadia and quite a lot of companies that we do. So I know about it. I think we're still a long way off from that.
When you guys think we will have, this something that can, basically as close to the human intelligence as possible. What here what they do. When you say human intelligence, meaning the single thing that you probably watched from the past, like iRobot or the term not the human part of it. like Age of Ultron time. Yeah, exactly. But I'm too part of the I wouldn't put a year on it. What is slopes are for what is slope? No, maybe like 30%. Really to get the next 30% and that would take at least I would say an extended 15 years. But
there will be a lot of security problems with it, if you understand. And really and truly more time, some products or some services are built, but it's just we won't call it a population adapt to that type of thing. So there's a lot of security issues and all of those things that they have to take into consideration because we get up today and we see and it's robot in front of me and every single thing on me, I'm like, I'm scared as when people in the movies are always think. I think there was one of Will Smith, just called the robots and take over the whole place. So there's a lot of security issues like that and people very weird. But it's the same thing like COVID come and everybody has this and the vaccine, everybody know that. Nobody know you want the vaccine until work say, yo, I want to take the vaccine. And so there's a lot of that that will have to come into place with people that say, yo, you have to live with them or you have to use them. You get what I'm saying? So really and truly the point is that you don't need around 20 years years, but it wouldn't be 100% there. They get maybe 70% in the next 15 years, but it wouldn't be 100%.
I think we have a system that has probably maybe military or
because I think they already have military AIs and stuff like that, which are used over in literally right now they're being used over in Ukraine and that's for
I think it's automatic killing and so on.
So yeah, right, I think that the entity that will develop at first is military or government versus private company.
I think it would be military funded or government funded, meaning it would be directed solely for the purpose of military use. But in terms of like using the business and population, majority of the general population using, I don't think they would have to keep that whole year. Or if they do, I would say it's mostly for households. Like for the smart homes and stuff like those, you can have like AI houses that really watch your babies and all of those type of things and then just go out and not worry anything about the house, everything is fun and spam. If someone come and deliver things, the AI will actually handle all of those tasks and stuff like that. You get it? So
just saying, so based on history, right, there tend to be two industry that push technology to human. Yes, military one, suddenly the oil industry will be a state that are and yeah, I don't want to repeat this, but according to that being said. And then third is pretty much finance. People want to get richer and trying to find the best way to do it. So those two industries tend to push technology.
I would say the core industry. I would say the movie industry.
Oh.
Anything that has to do with movies and stuff like that, creating graphics and all that.
You know, I think that's from for the movies, the type of thing that we're using is started out from the world industry. A lot of stuff when coming with the clinical or just understanding sex robot, all of that. Yeah. So, but yeah, for safety, just in case anyone don't want to get our movie. Yeah.
Sorry, so the last question. Do you guys think that overall the development of AI will be good for humanity or ultimately bad?
I would answer that it's like war, we can use it for value.
I would say when you use all the internet is right now, you can have a trajectory to what like the internet has opened so many opportunities for the world. There's so much information and data out there, so much good news of it, but it's still being survived. Yeah, so thank you for that.
Even if it's answer, because you have to think about what are the side effects. Yeah, there are cases seen a prediction about job industry going to be affected. We all are facing a lot of people without jobs. What will happen? We are exposed to
Then of course, what is it for humanity to do? We do one shows about how AI take over humanity, just get big part and they not much. Good thing. Technology always puts a lot of progress, communication, we, of course, the ones that are invested in tech, finance, and support nature. So post-regulate help us to create new avenues to make this world something like safer, healthier, information. So it's both sides of the
Well, an argument, some of the difference is in the AI is at least you think this there's a lot which you can, have some control of the internet or have some control of certain technology. But let's say, for example, this AI technology has agency, so it can act on its own. Do you guys think that because it may have that ability, that may have some ramifications in the future, like negative ramifications, but that it can maybe act on its own accord, if you have to be told that you do this. Let me do this.
Well, I would argue that, for instance, every single one of them can after you can go to the term law or your policies and laws that actually go there and constitute them that says you kill a material with the constitution. So I guess you can put that in the infrastructure when you develop this AI, so at the final say they can go in the morning and can learn as much as you want to learn. But when you actually press a certain form of button, X, Y, or Z, or policies that come into place, they can't cross that line. Because they will shut down the people. Well, it's kind of.
Oh, okay, well, one may argue that it may be hard to figure out what it's hard. Or basically, when you get to a point where you can't control it before you can figure out what those properly is. I mean, that's a big debate nowadays where like we're actively progressing AI, but there's not a lot of conversation. A lot of people have made arguments about this, there's not a lot of effort being put into the ethical side of it. Should we keep doing this? And the other things. What would determine there to be by the person? Well, that's a good question. When it comes down to the goal alignment problem, because one big thought experiment someone that people always raise is let's say the goal is set for the AI is to benefit humans. Let's say that's a goal. It's a very big goal. Let's say the AI determines our to benefit humanity. Sharing the world is more population, so that we feel humans, so that there's a higher chance of humanity survival. Now, let's say you have that system on the system, so that when you allow the AI system to kill half of humanity, you just made a the question was, would you allow that there will be policies put in place to give it for allow supports? What if we basically want to have the power to do whatever we need to do before we let's say anything will tell us that we want to do that, then what we would allow would be matter, just kill how humanity. Let's say that control of nuclear substations. Why would we do AI? More and more control over everything. We can like living tonight, like someone who chooses to buy the time like right? Then might someone say, you can also think that if they right? So the AI is such a god, right? There is God, I can say or if you have an AI like another AI, something you can reach that line. So one day I can't do that. Well, there's two things
First, AI is designed by you. And unless we get to the point where, as Jordan pointed out, AI design itself, they're exposed to folks going to not only all of the conditions. Yeah. So that's one thing to think about. And two, there's like too many convoluted limits or things that should or should not do depending on different scenarios. And you know, you have to train the AI to learn. As well, if you have a self-taught AI or yeah, then that can be what if, for example, design not so large missiles after China, but they thought missile coming, no one responding, and let's just try to can send missile to stop cutting to that missile and just stop it, and then something goes wrong. So there's with the whole evolution and the learn what to do, just in case there's no limitation for that specific scenario, yeah, that could be a bad decision or a good decision from the AI, depending on how it turns out and how you manage to view that decision. And then the third thing is geared towards how it impacts our social, basically our way of life. As mentioned earlier, let's stop for humanity. Do what are the limitations? What is okay? I'm going to start here. I think I lost him too much.
So, to me, what determines that AI is fair about it is what is all by the order for the you got to find this. Say we get a business. You see the video and you are TikTok released by the government. Cross actions. If that is to be large, we right? Because we're going to get some weed, right? And it can trouble, when the year goes, yeah. Okay, so it's one regulated that these crops, they use instead of the whole trunk, they use gravity, so they can traverse two gravity. They can traverse two speed with those two time. And pick up and speed big. Give us enough. Like a warp, right? One time, follow the and so if these are some things that exist, right? How did they come to know how to build craft? Oh, right? So these could be things, right? How did they know how to manipulate gravity? We don't understand.
I mean, it's pretty much over time when we follow the fact humans battling up the 1600 we expect we would be,
so what would be that AI read understand we can reach and they will come to a conclusion. So we have a barrier because we are just going here, we not say, or the subconscious say, we are actually well, so we're just over here. And everybody's like, I'm going to do that. Because, whenever you just learn about understanding reasoning, you can remove bias. That's the thing. Like, we find like, lion, which is close, like, to say something. Humans do what we do, looking at chat, because, we consider intelligence. No, they're wrong. So, now try to say, maybe at a certain level of intelligence, we are going to stop certain level of things.
So you're saying basically it's going to become so like without emotion, like the nuclear part. Humans are emotional beings. So any decision you make kind of has to take into account. Because let's say it's going to color her, right? How many humans are right? Let's say if one of those humans are heard of the humans, like people close to you. Right? I'm like, yeah, I understand here. Right? If they're going to have a decision here, right? But if you think about like most humans aren't really thinking about everybody like person in India and like most humans are concentrating on like themselves and their direct people around them, their family, they look out for them. Yes. Like in everything decisions, you're not making decisions thinking, all right, what decision I make affect the person in India or Africa? No, you're saying, okay, like do I have food on the table? Does my family have food on the table? We don't care about like somebody in Africa in this world, like dying, which is a part of the things. When it comes down to like survival, like the animal kicks in, you're really just thinking about my survival and like the people closest to survival. So yes, rationally, you might say, okay, killing half the humans in the long run, yeah, will ensure the survival of the human race, but like humans don't think that. Like, they just humans don't think that.
Long term, yep.
Yeah, well, that's something so easy. It's like, so you may have different views on things that I have different views on. Like politically, you may like think certain things that I don't think it's gonna like crazy. Like that's a whole other. I don't know. So on the basis of the put that into a system, so on every single one of us you need say you know make an AI with some with a general span of thinking or if you want like really develop like different sets of thinking or thinking like you think like you everybody. What is that about? Yeah, you relatively unique, but you have met them body on a person. And not only one of some like in the entirety of human system. There actually have these couple of people that similarly our experiences are relatively unique. Well, something that I said in one of our discussions was with virtual reality and AI, they'll be able to observe what's such a little, then they can do the prediction. Maybe I'm sure someone will to environment. So realize basically same environment then to be able to we are similar and these are joint that's pretty for you to think you yeah, that's